Hi everyone, welcome to the playlist on BFS template. In this video, we'll solve this problem graph valid tree. So as an input, we are given a graph of n nodes and the set of edges between those n nodes. We need to return true if it makes a valid tree, otherwise we return false. So what are the properties of a tree? The tree is overall a connected graph. Like basically from each node we can reach to each other node and there is no cycle inside it. So our first algorithm will be, we will detect the cycle using DFS or BFS and we see if everything is reachable from our first node, right? Second algorithm will be, we'll say okay, a graph of n nodes become tree when there are n minus 1 edges which connects each other. So we'll see the other algorithm, which is okay, we see if the total number of edges are n minus 1 and there is like everything is reachable from our first node, right? So let's start with the first algorithm. I say okay, because we are given this is in the form of edges, let's create adjacency list from here. So okay, graph is empty for each node. For my edge in edges, I add my edges in the form of adjacency list, right? This is done, and now I will have my scene set, which is false for each node, and I get my status from DFS of graph, and DFS starts from 0th node, and I return if I have some status which is true, which is I detected a cycle, I return false. So the DFS has to return and tell me whether there is a cycle or not. If it told me there is a cycle, I return false, that oh, it's not a tree. Otherwise, for each of the element inside scene, this is false, again I return false, that it is not a tree, otherwise I return true. Let's write DFS now. I have my graph, I have my source node, I have my scene, and my graph of source should become true. Okay, for my adjacents in graph of source, if scene of adjacent is true, which means there is a cycle, I return true. Otherwise, I call my status from DFS on graph from this adjacent and this scene. But before that, I need to remove the node from the source to this adjacent, which is okay. When I'm calling from this guy to this guy will again see okay, I am visiting already seen node, then there is a cycle, but there is not. So I need to remove this part, which is like removing the path from where I came to this current node. So what I do is I say okay, graph of adjacent dot remove source. Once I'm done, I can add graph of adjacent dot add source. After this is done, I say okay, if status is true, which means there is a cycle, I return true, otherwise I will return false. Okay, let's see if it works. Okay, this is, oh, I have to add scene here. Okay, let's submit it. Awesome, it works. Let's see another technique where I don't need to modify my graph, but I will pass a parent pointer, which helps me not I don't want to modify the graph, and parent node will tell me where did I came from, so I don't go and explore that path. So that's the same setup like the way we have done it. All I need is I say okay, this is my graph, this is my source, and I have parent node also, and before and I'll call it with okay, the parent of 0 is -1. So okay, if adjacent is parent, I'll continue. Okay, because I don't need to explore that path. Otherwise, if this is seen, I return true. I don't need to do this, I don't need to do this. That's it. Okay, let's see if it works. It takes 5 arguments. I'm passing the 5 arguments. Okay, I need to pass the parent also, right? I need to pass source as a parent. Okay, let's see. Okay, let's submit it. Awesome, it works. So guys, in my earlier videos we have tried changing this, like for example this code into a non-recursive one. I don't want to go in much detail about this. This is very easy to convert it into recursive, non-recursive code, but I want to explore this, like this code should be changed to the non-recursive and it will give us a lot of learning. So let's see how do we convert it into non-recursive code. I say okay, I have my DFS which is on the graph. Okay, I will have my parent map, which is nothing, and in the stack I will put my 0th node, and my parent map of 0 will become -1. The parent of 0 is -1. What I do is, while I have something inside my stack, I'll pop it, and once I have popped it, for adjacent in graph of cur, okay, for example, if I'm here, right, and now I started exploring this guy's adjacents. So if at this position I'm at this position, the current parent I already know, I just will check if I am exploring next guy, which is 0, and if it is my parent, I don't want to explore it, which is if parent map of cur is equals to adjacent, I don't want to explore it. I say okay, continue. Okay, I mean at this place I said okay, I'm at 1. I say okay, if one's parent, which is 1 is cur, one's parent is 0, I don't want to explore it. Otherwise I see okay, if adjacent in parent map, this guy is already in parent map, which means this guy has already been explored, because this parent map is also acting as the set of nodes which has already been seen. So I return that this this graph is not a tree. Okay, this function, this DFS now this time is returning the status whether this graph is a tree or not. Otherwise I will add the parent map of adjacent as cur, and stack will take adjacent. Once I'm done, I'll return true only if, or let's say length of parent map should be n, that the number of nodes that I visited should be the n. I can pass this n here. So I just don't need this setup, I don't need scene, I don't need this also. What I do is I say okay, return self dot DFS on graph with n nodes, and this will return me the status. Let's see if it works. Okay, let's submit it. Awesome, it does. So let me re-explain it. So what I did is I say okay, the parent map of the first pointer, which is 0, is -1, which is like sentinel, and now I start exploring the entire graph, and whenever I am using the parent, I will check if the current node is my parent, then I don't explore it. Otherwise, if this was already in a parent, which means I have already explored it, then there is a cycle inside it. Otherwise, if I explore the entire graph, then the total number of scene nodes should be n, right? Because the length of parent map will tell me the total number of scene nodes. So this was based on, you know, our first algorithm. The second algorithm is very easy. So the second algorithm says okay, check whether I have n-1 edges or not. Okay, if I have n-1 edges, everything should be seen. So for that, let's see this. I say okay, if length of edges is less than n-1, is not equals to n-1, I return false, that this guy cannot be a tree. Otherwise I created this, and now I will have my scene set. I can do my DFS, okay, on graph, which marks everything as either seen or not, and the total number of nodes that I see should be n. So for that I say okay, graph should start seeing here. Okay, and once, so I don't need to get any status here. All I need is I did the DFS from this position, and I check if something is not seen, then I return false, right? So I say okay, def DFS self of graph source and scene. Okay, I just will explore the entire graph. Now there is no concept of parent or, you know, cycle detection or anything. So I say okay, my scene of source is true, then for each of the adjacent node in my graph of source, okay, I will add this to if I see okay, if not scene of adjacent, I'll say okay, go and DFS on yourself. I will pass this adjacent and scene. That's all I need to do. My DFS just explored everything and marked everything as true, and the goal is I want to see everything should be visited now, because I've already checked the length of edges should be n minus 1. So the graph where I have visited everything and the number of edges are n minus 1 will be my tree, right? Let's see if it works. Okay, let's submit it. Awesome, it does. So again, we can convert it into non-recursive and all, but I don't want to go into that. You know how to do it. So but let's, because this playlist is on BFS, so just for the sake of completion, let's do everything by BFS also. I say okay, self I have graph, and I can take source and scene also, that's not a problem. And my queue will contain collections.teak on this source node, which is actually 0, right? So it's not a problem. Otherwise, now while I have my node inside the queue, I'll pop it. Okay, then for each of the node which has not been seen, I'll push it inside my queue, right? But let's mark it. So my scene of source is already seen, right? So I will mark it. And now for adjacent in graph of curve, if scene of adjacent is not true, okay, q.append adjacent, and my scene of adjacent should be true. That's all I need to do, and I just change it to BFS. Okay, let's see if it works. Let's submit it. Awesome, it works. So I hope guys you like this solution. If you like this, please hit the like button, subscribe to my channel for more videos on BFS templates. See you guys on next time.